Today's lesson is on section 4.4, find slope and rate of change. We're going to start talking about a topic that's going to be very important to us the rest of the year, rest of this chapter, next chapter, things we're going to use a lot in algebra, or something that we're going to need to know about, which is slope. Slope's going to help us with graphing, slope's going to help us with word problems, a lot of connections with slope when it comes to linear algebra and a lot of the topics we're going to continue to talk about. So, very important topic we're about to start right here in section 4.4. Slope, what is slope? Well, the first thing I usually have students do is I write down kind of a side definition here that I've made up, not the book one, but something that I like to think of or I'll talk about when I talk about slope. I say that slope is a measure of the steepness of a line. So measure of, if you're taking notes along with me here, this is definitely something I'd still want you to write down too. It's the measure of the steepness of a line. What am I talking about with steepness? Well, if I look at this line that I have here on the graph, okay, obviously this line is a little steeper, this line's a little flatter. You know, this one actually we'll talk about having a negative slope. Like there are different angles or different ways this line can be set up. Each of these has some kind of number associated with it, and it's kind of, again, it's a description of how steep that particular line is, how fast it's changing and then the y direction with respect to the x direction. Again, we'll learn this more as we go on, but if there's a line with this kind of steepness right here, this kind of angle, it might have a slope of 3 or 2. Actually, I probably shouldn't say 3 over 2, but like something like 3 or something like 2 for a slope. If I have some kind of line that's a little flatter, it might have maybe a slope of like 1/2, like some kind of fraction, something less than 1 or 1/4. And if I have a line that actually goes down and to the right, it'll have some kind of negative slope, maybe like -1 or -1/3 or something like that. So just know there's different measures for the steepness of a line, and we're going to look at that and kind of investigate that, or start to today. And it's going to be very important with us, very important for us to make the connections we're going to continue to make in linear algebra, and that also will help with graphing as well. So very important concept to understand is slope. Here's the book's definition, also something I would like you to write down. And I'll kind of break it down to realize that, you know, it's a little bit wordier than my definition, but still isn't something we should be scared of. We still understand all the words that are in this definition. So it says slope. It says slope is the ratio of the vertical change to the horizontal change between any 2 points on a non-vertical line. What that's saying is, well, if I just kind of break it down word for word, the ratio, well, ratio we've talked about in class before. Ratio, one thing I can think of is like a fraction, okay, some number like a to b, or if I have some numbers there like, you know, 2 over 3 or something, but it's just a ratio of the vertical change. So this is saying the ratio of the vertical change between, I kind of got to read ahead a little bit here, to if I'm looking at any 2 points that are on this line. If I have 2 points on this line, if I know 2 points that this line goes through, the graph of this line goes through, I'm going to try to find the vertical change, which is how much do I go up or down between these 2 points. Okay, how many spaces, how many units. I got to count that or figure that out. The vertical change to the horizontal change of these any 2 points. Horizontal change is just how far do I go left or right between these 2 points. If I can find those two numbers, I'm going to put those in a ratio. Let's say up or down in this particular, between these 2 points, let's say I go up 7, and let's say I go over 8. Well, then my slope would be 7 over 8. And that'd be the measure of how fast this line is increasing, the measure of its steepness, how fast is it going up as compared to it's going over. So there's kind of an example of how I would find a slope, or what a slope could be for a particular line. Also, one thing to jot down with this that maybe students have heard in the past or heard before is we talk about this since it's the vertical change, since this is like the up and down change, over the horizontal change. A phrase they may have heard before to help them with this when they were learning slope is something like rise over run. And that's just kind of a way to remember what goes on top and what goes on bottom when I'm figuring out the different changes, the vertical and horizontal change. Rise, again, that's referring to the vertical change. How far do I go up or down? In this problem, let's say we went up 7. The run is 8. That means I went over to the right I went over 8. Sometimes you may even see them make this kind of triangle shape here where I say, oh, I went up 7 and over 8. So I went, or sorry, oops, 8 in this case, not 6, but 8. So I rise, my up and down, my vertical change. My rise is 7, my run is 8. So that kind of phrase also may help students remember how slope works, or at least how to arrange the numbers once I put them in my ratio. Besides just being able to find the measure of the slope of a line, we're also going to talk about there's 4 different types of slope, and these will relate nicely to the numbers that we actually find for the slope. So there's a good relationship here between positive slope, negative slope, zero slope, and I've got it covered up there, but no slope. So these 4 sketches, or these 4 graphs, I'd also like students to have in their notes, if you're taking notes along with me here. Make a sketch of each one of these and what type of slope it is. We call this line here in the top left, we call this one positive slope. It's any line that, it's like as I'm reading the book, I go left to right. If this line is going up, as I go left to right, so that's a positive slope line. Doesn't matter where it is in the grid, if it's down here or up here, or if it's really steep, or if it's a flatter line, doesn't matter. Any line that's going up and to the right, we're going to call that a positive slope line. It makes sense because when I find the slope of this line, it'll always be a positive number. Again, kind of like I described before, like maybe the slope of this line could be 1/4, or 2, or 5, or something. Okay. Whenever I see a positive slope line, I know that my answer should be positive when I actually figure out the slope of it. Going to this next one here, the top right, negative slope line is just any line that's going down and to the right. Whereas again, if I think about it, I'm reading a book, I go left to right, and the line is going down, that's going to be a negative slope line. Again, doesn't matter how steep, if it's this steep, or if it's way over here, or up here, or it doesn't matter. Okay, or if it's a flatter line, doesn't matter. Any line that's going down and to the right is going to be a negative slope line. Again, what I love about the connection for this is it makes sense that if I find the slope of this kind of line, then I'll get a negative number, like let's say -2, or -5/2, or -1/3. Okay. So the numbers, the numbers also go along with what you find for the different types of slope. The bottom here, two here, we have zero and no slope are kind of like our, you could say special cases. One that's just a horizontal line and one that's just a vertical line. Zero slope. The way I always describe it, or one way I describe it to remind students which slope is zero slope and which one's no slope, the one how to keep them apart from each other, or how to realize the difference, is I talk about, well, this is a positive slope line, and if I can make this is a negative slope line, right in between those is 0. It's just like on a number line. Here's 0, and over here I'll have negative numbers like -1, -2. Over here I'll have positive numbers. So in between, what's in between positive and negative numbers is 0, is right in the middle of those two things on a number line. Well, same thing here when I'm finding slopes. Again, here's a positive slope line. Oops, if I can get the line just. There's a positive slope line. There's a negative slope line. What's right in between those is 0 slope. So that's maybe kind of one way to remember. That's the 0 slope line we talk about. And then no slope is the straight up and down case. And I also talk about when you're skiing or snowboarding, if you're trying to ski or snowboard on a slope, and this is what your slope looked like, you wouldn't be able to do it. There's no slope there. It's just a cliff. You'd fall off, unfortunately. So I talk about that one being no slope. And if you were trying to downhill ski on a 0 slope line, you'd be going 0 miles an hour if you didn't have anything to push yourself along. So another way I can kind of remember which is which in terms of 0 slope and no slope. The numbers will also show this, but we'll work on that soon enough. If you found a 0 slope line, you would find a slope of 0. And no slope will look a little different, but we'll talk about what that looks like here as we move on, as we start working and finding the slopes of lines. So there's 2 ways that I talk about finding the slope of a line. One way is if I have the graph of it, just like I do here, we can find the rise over the run. We can see between the 2 points that are on this line. If I want to find the slope of a line, I just need 2 points. But between those 2 points, I can just count how far do I go up and how far do I go over. What's the rise over the run? What's the slant, the angle of this line? That'll give me the measure of steepness. That'll give me the slope. So for this particular graph, I have the point 3, 2, and 7, 4. It looks like I go up 2 spots if I want to get level with that second point. And I'm going to go over 1, 2, 3, 4 slots. So I went up 2 over 4. So it's rise over run, so 2/4 is my slope, which if I reduce it, and I should always reduce my slopes if I can, that reduces to 1/2. So that's the slope of this line. Again, it makes sense that this is a positive slope line like we talked about on the previous page. This is a positive slope line. It's going up and to the right. So what do you know? My answer was a positive answer, so that should always make sense. Well, how would I get a negative slope line or a negative answer? Well, I'll kind of show you that here. Here's a line that we know is negative slope from that previous page. It's going down and to the right. It's got this kind of slant to it, down and to the right. So I know that this is going to be a negative slope. So my answer should also be negative. Well, how does that happen? Well, again, think of this as rise over run when I'm making my slope. Well, if I talk about rise, in this case, I'm actually going to, if I'm going from left to right, I won't rise to get to the next point. I'm actually going to go down when I go from point to point. If I start at 0, 4, and I'm going to go to 4, 0, and I always usually do that, I start on the left and go to the right. You can actually go the other direction, but I just think it's easier to go left to right all the time, as you'll see. But in this case, if I go down, since I'm going in the negative y direction, I'm going down on the y along the y-axis. In this case, I can think of this being negative. I went down 4, so I'm going to say I went negative 4 in the y direction. And then I go to the right 4. So I'm going to have to the right 4 along the x-axis, that's positive. So I went down 4 for negative, but I went to the right 4, that's still positive. So I have negative 4 over 4. And what do you know? Negative 4 over 4 gives me negative 1, which is negative. That's the type of slope line that I have. So again, you see the numbers will work out too. In terms of if I have a negative slope line, I should get a negative number for my answer. I'm going to show us one more thing in terms of finding slope. That can be a nice trick too. I mentioned there's kind of 2 ways you can find slope, or at least there's 2 ways I'm going to talk about it. One way is, like that previous page, if I have the graph, I can count the rise over the run. I can see how much do I go up and over. That's a way to find the difference in the vertical change and the horizontal change. Well, what if I don't have those points? There's going to be problems where, right, I don't have the graph. There's going to be problems where I just have the points. Like what this previous problem here that I had, the points were 3, 2, and 7, 4. So what if I just have those coordinates? I know that these are 2 points that are on a line, and I want to find the slope. I don't have the graph, but you'll find here, what I'm going to show us here is we don't actually need the graph, though. If I want to find the vertical change between these 2 points, let's say, going back to the graph to just kind of help us see how it works. Here's where the 0.74 is, at least in terms of how high. Here's where the 0.32 is. So I want to find this distance right here. Well, how would I find that? I know this one's at 4 and this one's at 2. So to find the distance between them, I would just subtract those 2 numbers, 4 minus 2. That would give me a distance of 2. That's how much I rose between those 2 points. So essentially, I'm just taking 4 minus 2. I'm subtracting these 2 y coordinates. This is my rise. Going back to that problem as well, again, just to kind of show how this works. In terms of my x coordinates, it's 3 and 7. So that tells me this point I went over 3. This point I went over 7. So to find the distance, I'm just going to kind of clear some space here for us. To find the distance between those, here I went over 3, here I went over 7. To find the distance between those, the horizontal change, I would subtract those, like 7 minus 3. There's a distance of 4 between those. That's how much I ran to the right. So 7 minus 3. And that's going to equal 4. Well, that's, again, if I just subtract those coordinates, I find that I went up 2, I went over 4. That's the distance between each of those. 2 over 4 just reduces to 1/2, which is what we found when we found the answer of this using the graph. So what did we just do there? What happened? Well, I find that if I want to find the distance or the slope, if I want to find the slope of a line and I know the 2 points that are on it, I can just subtract the y coordinates and subtract the x coordinates, and that'll give me the slope. There's a little formula that shows this that we'll see in the book or on MCA sometimes. And this is something I'd also like the students to copy down. This formula right here in this box is the formula you'll often see when it talks about finding the slope of a line. What it's saying here is m, and m is designated in algebra as the variable to stand for slope. But if m equals, if you're trying to find the slope, m equals, well, all it's saying kind of basically is subtract the y coordinates on the top of your 2 points and subtract the x coordinates, just like we did in this problem. In the green, I subtracted the y coordinates, and in the blue, I subtracted the x coordinates. If I just subtract those numbers, put them in a ratio, put them in a fraction, that's going to give me the slope of my line. So, and the y2s and the y1s, all that's saying is just make sure you stay consistent when you're subtracting. I always start from one point and go to the other. So kind of like I had up top here. I took 4 minus 2. So then when I subtract the x-coordinates, I have to take 7 and subtract 3. I just got to stay consistent. I always go from one point to the other. As long as I do that, I'll be able to find the correct slope of that line without even having a graph. Oops. So then just showing a few examples here of how we can do that again, or find the slope of a line without a graph. These problems say find the slope. I'm going to try to find the slope of this line. I don't have the graph right offhand. I have a graph here I could graph it on, but I'm going to instead use the method we were just talking about, subtracting the y-coordinates, subtracting the x-coordinates. That's going to be like finding the rise over the run, and that'll be the slope of my line. So for this first one, I have the points 5, 2, and 4, negative 1. I'm going to start by saying 5 minus 2, or sorry, not 5 minus 2, but 2 minus negative 1. I'm going to subtract the 2 y-coordinates. 2 minus negative 1. And it's minus negative 1, so realize, like we worked on in the past, that's going to be like a chop-chop situation. I'm actually going to end up adding those two numbers together. And then if I did 2 minus negative 1, I got to go 5 minus 4 on the bottom. 5 minus 4. 2 minus 1 gives me 3. 5 minus 4 gives me 1. So the slope of this line, if I just kind of put it in a fraction here, is going to be 3 over 1, which is also just a slope of 3. If I graph this line, we'll see that that's what it should look like too. 5, 2, 1, 2, 3, 4, 5, up 2. There's that point. 4, negative 1 is right here. Graphing that line, it's a positive slope line. What do you know? Because I found a positive answer, so that should make sense. And if I just kind of do my rise over my run on the graph here, it looks like I go up 3 and over 1. So what do you know? That's also a slope of 3 over 1, which is 3. So again, that should all make sense. I could find the slope either way, but just showing you this kind of a shortcut way, if I just subtract the coordinates, that's a way I can do it. I'll look at one more example here with this. So same thing on this one. I'm just going to subtract the y-coordinates, subtract the x-coordinates, and that should give me my slope. I'm going to say 3 minus negative 6 on the top. And again, 3 minus negative 6 means I'm going to have to chop. I'm really going to have to end up adding those two together. Negative 2 minus 4. Negative 2 minus 4, that's how I'm going to write it. 3 minus negative 6 ends up being adding, so now I just have 3 plus 6, which is 9, over negative 2 minus 4 gives me negative 6. And if I have a fraction, if I get an improper fraction, I'm just going to leave it in that form. It's actually going to be easier for us to deal with, but I should always reduce it, so it's like the fraction negative 3 over 2. So what does my line look like? Well, if I graph negative 2, 3, here's that point. 4, negative 6, that's down here. What do you know? It's a negative slope line. That should make sense because I found that I have a negative for an answer here, negative 3 over 2. And if I go down, looks like down 9 over 6, that gives me a slope of negative 9 over 6, which reduces to negative 3 over 2. The first day of slope is always, working with slope is always kind of a tough day just because it's something brand new, but it's something important, and there's a lot of connections to put together. But we'll keep working with slope, and as we work with it, I think it'll get much, much easier for everybody.